Alright, so now we're going to go through some problems related to that formula that we derived at the end of the last video. So remember that Tn, so the nth term, is equal to A, so that first term, plus n minus 1 times d, d being the difference. Alright, so let's have a look. If we're looking at that problem that I showed you in the first video, so your first term is 5, and then you've got x and y, and then 32. So what we need to look at is the fact that we know that 5 is our first term, and we know that when we go to x, we've added d, and then to get to y, we add another d, and then to get to 32, we add another d. So all up, we have 3d. So we've added 3d's, and we know that that is going to be equal to the difference between 32 and 5. So 3d's is equal to 27. Because when I added d 3 times, I added 27. So what's d equal to? Well, d is equal to 9. So if I know that the difference is 9, then I can work out what the other terms are. So x has to be equal to that first term that we started with, plus the 9, so x is equal to 14. And then y, well, that's equal to the 14 that we just worked out, plus another 9, so we get 23. And you can double check, because if you add 9 to 23, you end up with 32. So that's how we can work out the missing value of the terms. So looking at this first pattern that we started with in the first video, so 4, 7, 10, 13, 16, and they want us to find the 50th term. So first what you need to do is work out what all the missing values for the formula are. So again, we're just going to write it down, our formula. So Tn is equal to A plus n minus 1 times d. Now we know that n is equal to 50, that's what they want us to work out, the 50th term. A, so A is your first term, so A is equal to 4. And d, the common difference for this pattern, well, it's going up by 3's, so d is equal to 3. Alright, so whenever you get one of these ones, start off with just defining what each of the variables are, and then substitute in. Now, write down the formula that you are substituting into. At this point, we've only got one, but there will be a lot more before we finish this topic. Make sure the marker knows what you're doing. Alright, so what we're trying to work out is T50. So the 50th term is equal to the first term, 4, plus, and it's 50 minus 1, because there's going to be 49 differences, and the difference is 3. Okay, so 4 plus 50 minus 1 times 3, we end up with 151. Now we already know that because we did work that out, but that's how you use this formula for this type of question. They could reword it and say, well, how many terms are in this sequence? So let's have a look. We've still got those things that we know. We know that A is equal to 4. We know that D is equal to 3. That hasn't changed. But when they say how many, well, what that means is N is the one that's unknown. Okay, we don't know what N is. That's what we're being asked to find out. But what we do know is this term here. That's the new piece of information we have, 598. So that's the term. That's what we're going to substitute in for T. So we don't know what N is, but we know that the nth term that we are looking for is equal to 598. Okay, so they're the knowns. Start off with our formula again. So Tn equals A plus n minus 1d. So then the term 598 is equal to the first plus, and we don't know what n is, we need to keep it as n minus 1 times 3, because we know the difference is 3. And then you're just solving an equation. Okay, so we've got the plus 4, we want to get rid of that. So 594 is equal to 3 outside of n minus 1. And then we need to divide everything by 3, because we've got that 3 in front of the brackets that we don't like. So when I divide by 3, I'm left with 198. So 198 is equal to n minus 1. So what's n? N has to be 199. And the beautiful thing about this is you can then double check. If you put 199 back in to the formula there, you would get 4 plus 199 minus 1 times 3. And that'll give you your 598. Alright, this is another way they could ask the question. Same type of deal, but instead of giving you the term, they're saying, well, is this part of the series? So we want to know that if I start substituting into that formula, can I get 1473 as an answer? Alright, so same deal. A is still equal to 4, D is equal to 3. But now what we want to know is t to the n equal to 1473? Okay, well, let's do some substitution and see. So what we're going to do is substitute in 1473 for t to the n and see, is there a value for n that I can find that will make this true? Okay, so a is 4 plus n minus 1 times 3. So it starts off exactly the same as the last problem. Okay, so again, you're going to subtract the 4. So 1469 is equal to 3 outside of n minus 1. And then you're going to divide by 3. Now, here's our issue. If I do 1469 divided by 3, I end up with 489.6 repeater. And there's my issue. N has to be a whole number, because what is n? N is just a counting term. 1 term, 2 terms, 3 terms, 4 terms. I can't have 489.6 repeater terms. I can have 489 terms, I can have 490 terms, but I can't have 489.6 repeater terms. So what that means is I can't solve this for a value of n that works, because n must be a positive whole number. So therefore, 1473 is not part of this sequence. Now, if you were able to solve that in a way that gave you a whole positive number for n, then that would have been part of the sequence. All right, another variation. They want to know what is the first member of this sequence that is greater than 5,000. Okay, so we want to know, when do we get over 5,000? What is the number that's over 5,000? So again, start off with what you know. A is 4, D is 3. We don't know what n is, but we know that we want Tn to be greater than 5,000. Okay, so we're going to have an inequality to solve for this one. We've been working with inequalities on and off during the year, so that's all right. So Tn equals A plus n minus 1 times D. And we want that to be greater than 5,000. So what we're going to do is say that that is going to be greater than 5,000. Pretty simple. 4 plus n minus 1 times 3. We still don't know what n is. Okay. And then we're going to solve this the same way we would normally. Subtract your 4. So 4,996 must be less than 3 outside of n minus 1. Dividing by 3, that leaves us with 1,665.3 repeater. Has to be less than n minus 1. Now stop and think about that. What that means is that n has to be greater than 1,666.3 repeater. Yeah? So where does that leave us? Well, what that means is that the first one greater than 1,000 would be the 1,667th term. So that tells us which term. They want to know what the number of the sequence is. So what we need to do is substitute n equals 1,667 back up into here to work out what that term's going to be. Okay, so the 1,667th term is equal to 4 plus 1,667 minus 1 times 3. So that is equal to 5,002. So the first term that goes over 5,000 is 5,002. So be careful make sure you look very carefully at the difference between question 4, where we want to know if that number is in the series, and we can say no, it's not because I get a decimal. And when is it greater than? In this case, the decimal is fine because we're looking for what's bigger than that, so I can round it up. Okay? All right. Have a look at this. It's a variation on the one we just looked at. Instead of wanting greater than 5,000, we want the first positive term. So you can see we've started with a negative here. So this one's a different one. Up until now, we've been looking at the same sequence. We've got a different one now. Okay? So our first term, our A, is minus 50. Okay, so what's our D? Well, the numbers are getting larger, aren't they? Minus 57 to minus 47, our difference is 3. And we want to know when is this greater than 0, because that's what positive means. So Tn has to be greater than 0. Okay, but we don't know what n is. So let's have a look. We start off with that wonderful formula again. By the time you get through this exercise, you should know that formula backwards. Okay, so we want this to be greater than 0. So we need minus 50 plus n minus 1 times 3 to be greater than 0, and you're just going to solve. Okay, so I'm going to take 50 over to the other side. And then when I divide by 3, we end up with 16.6 repeaters. So again, the decimal is okay because we want to know when is it greater than that. So no worries, 16.6. So then add your 1, we end up with 17.6 repeater. Has to be less than n. So what that means is that n must be 18. Okay? So let's work out the value of the 18th term. So the 18th term is going to be equal to negative 50 plus 18 minus 1 times 3. And so we end up with 1. So the first term greater than 0, the first positive term in this series, is 1. Now what I'm going to show you here is a little bit of a cheat. Now be very careful. This is a trick that you can use in an exam to check your work, but this isn't going to get you marks for working. Okay? If they give you a question like this, they need to see all of that working out. Okay? That's what's going to get you the mark. This is just a way of checking if you're right. So what you do is you put the first term in. Now this works for arithmetic sequences, no worries. First term in, negative 50, okay? So you go negative 50 equals, hey, negative 50 equals negative 50, right? And then you say, well, what are we doing each time to work out the next difference? We're adding 3. So plus 3 equals, okay? Gives you the second term. Now keep hitting equals and have a look. Your calculator keeps adding 3, and what you can do in the exam is spend a total of about 2 seconds to go, hey, there's my first positive number, 1. I know I did my working out right then. Excellent, let's move on. Neat little trick. It won't get you marks. It won't get you anything if they're asked to prove or show, but you can double check your work. Okay, and that's going to come in really handy, not so much for this one because adding 3 isn't such a big deal, but when you start doing the financial ones and they're big numbers and we're doing it over 48 months or something, it can be a handy little thing to just double check if you got it right or not. Okay. Okay, so the last variation I want you to look at is this one here. The 5th term of a sequence is 25 and the 12th term is 81. We need to find the first term and the common difference. So this is a challenge for you before you come into class. I want you to have a go at that, and we're going to have a look at it tomorrow. Okay?